Suppose that we want to find the smallest element in the stack. For example, what is the minimum value of the following stack? One simple way to find the minimum value is to keep track of the lowest value as we inspect the stack elements one by one. For example, here's how we find the minimum value of 11, 29, 5, 17. The minimum value is initially 11. 29 is greater than 11, so the minimum remains 11. 5 is less than 11, so the minimum is now 5. 17 is greater than 5, so the minimum remains 5. To precisely describe the procedure above, we would introduce a new function that keeps track of the lowest value and convert the minimum operation to the new function. But this conversion process is rather cumbersome, so let's explore a slightly different way. Take a look at the following properties. Property 1. If top is less than the minimum value of remainder, then the minimum value of the stack top remainder is top. If top is greater than or equal to the minimum value of remainder, then the minimum value of the stack top remainder is equal to the minimum value of remainder. The minimum value of stack X is X. Property 1 says that if the top element is less than the minimum of the rest of the stack, then the minimum of the whole stack is the top element. Property 2 says that if the top element is greater than or equal to the minimum of the rest of the stack, then the minimum of the whole stack is the minimum of the rest of the stack. Property 3 says that the minimum value of a stack with one element is just that element. In short, to find the minimum value of a stack, we must first find the minimum value of the stack without the top element and compare this value with the top element. Let's look at some examples. What is the minimum of the following stack? There's only one element, so the minimum is that element, or 39. Example 2. What is the minimum of the stack 1439? From the previous example, we know that the minimum of stack 39 is 39, and the top element, 14, is less than 39. Thus 14 is less than the minimum of the stack 39. Therefore, 14 is also the minimum of the stack 1439. Example 3. What is the minimum of the stack 28, 14, 39? From the previous example, we know that the minimum of stack 1439 is 14, and the top element, 28, is greater than 14. Thus 28 is greater than the minimum of stack 1439. Therefore, the minimum of stack 28, 14, 39 is the minimum of stack 1439, or 14. Notice that we started from the bottom of the stack and moved up to the top. The direction of stack traversal is unimportant as long as we visit every element. Next, let's see a video demonstration that computes the minimum value of the stack 23, 17, 11, 19.